Okay, so this is practice test for test 4. Number 1, graph the parabola and then axis of symmetry. This is the parabola we have given. So first of all, whenever you have this type of parabola, find out the vertex. As you can see here, if you compare this equation with the standard equation of parabola, which is f of x equal a times x minus h whole square plus k, this number h and k, remember in front of h there should be negative sign, so there is a negative sign. If it's positive, then you can take that number as a negative number for that, but it's already negative, so just take that number. So h comma k is 3 comma 2, so that's your vertex. So because a, which is a number in front outside this parenthesis, is positive, which is 1 here, the graph of the parabola would be look like this, because a is positive and this vertex is at 3 comma 2. And here you have to find out one more thing, that's axis of symmetry. Axis of symmetry means this line, which is x equal 3. This is what we're going to plot it here. Plot the point which is 3 comma 2, that's your vertex, 3 comma 2. Plot this point, and now after that you might have to put some other points as well. You can take when x is 0, that is the easy point to find. When x is 0, here if you put x is 0 in this equation, it gives you, it's a y-intercept, which is 0 minus 3 whole square plus 2. If you do this calculation, that is negative 3 whole square is 9 plus 2 is 11. So when x is 0, the y is 11. That's your y-intercept. That is another point you can use to plot the graph. You need 0 comma 11. That's another point. What is that? So 0, so 11 is not there, so we cannot use that point, so we have to use something else. So let's use when x is 3, the value is 2. Let's say x is 4. Okay, graph the parabola and the axis of symmetry. Use a dashes line to indicate the axis of symmetry. Okay, if x is 4, this point is not plottable because that's out of our range here, so sometime it happens, that's okay. So find out the value of the function when x is 4. I'm trying to find out something nearby 3, so that is 4 minus 3 whole square plus 2, which is 4 minus 3 is 1, 1 square is 1 plus 2 is 3. So at 4 the value is 3, so I can plot that point here. At 4 the value is 3, I mean the value of y. Okay, so we plotted that. Now you can choose this one and you can just say, hey, this is my vertex, and another point is, what is that, opens up but goes to that point. So yeah, that's how you have to click that one. Okay, and you need axis of symmetry. So axis of symmetry should be through this point, which is you see in here. How do you draw it? Okay, I think I need one more. So let's say a line through this one, but I need the dashes line. So yeah, no, it's not giving me y. Okay, so now it's dashes. So let's check. That's right answer. You see, so you plot vertex, you plot another points which is plottable in this frame, and then you just plot this line, but when you choose the, you have to also make it dashes line. Okay, it's called axis of symmetry. Now what is the vertex here? The vertex we found, it's a 3 comma 2. 3 comma 2, that's our vertex. Okay, so that's number 1. The equation of axis of symmetry is x equal the x coordinate of the vertex, which is 3. So that's our axis of symmetry. And then domain in the interval notation, as you can see here, the domain is all the real number. Domain means what x value you can pick. There is no restriction for the parabola. So it's all real number, which is parentheses starting from negative infinity to positive infinity. Always keep in mind, for the parabola, the domain is all real number, but the range is the y value. So the minimum y value, as you can see, is 2 and 2 up. So whenever you have facing a parabola, the range starts from the y coordinate of the vertex, which is 2 in this case. So 2 to infinity, including 2. Okay, so don't forget that it's including 2 and goes up. So that's 2 to infinity. You see here for the range, here is the 2, and then it skips. Range means the y value. So when you walk on the y-axis, starting from 2, it is going up and up and up. So that's our range. This is very similar type of problem like previous question. First of all, you have to change this function into this vertex form. I'm going to just change it into the vertex form, and then rest you are going to do it by yourself. Okay, so how do you change this into the vertex form? F of x equal x squared plus 10x plus 21. First of all, complete the square for these two terms. So x squared plus 10x. Look at here. To complete the square, I'm going to just make some space here. I need to add something. To complete the square, I need to add the square of half of this number 10, which is 5 square. But I cannot just add some number of my choice. I have to balance this addition, so I'm going to subtract the same number. By doing that, what happens is, for these three terms, I can write down x is coming from here, plus sign is coming from here, and plus 5. This three terms gives you the square of x plus 5. So this x is coming from the first square, the 5 is coming from this third square, and this plus sign is coming from the middle one. And now we do the calculation between these two terms, which is negative 25 plus 21 is negative 4. So this is our vertex form. So as you can see here, there is nothing in front of outside this parenthesis, so a is 1. The vertex h comma k is negative 5 comma negative 4. Remember, it's supposed to be negative here, but it's positive. That's why we need to use negative sign. It's supposed to be positive here. That's why we have to take it as is, so which is negative 4. So that's the vertex. Now we can answer all these questions the way we did the problem number 1. But let's look at here. The vertex form of the function is, this is the vertex form, which is x plus 5 square minus 4. X plus 5 whole square minus 4. That's the vertex form. Check it. The vertex is negative 5 and negative 4. Negative 5 and negative 4. That's right. The x-intercept means when y value is 0. So that means when this function is 0, solve this quadratic equation. That gives you the x-intercept. X-intercept means when the function f of x is 0. But the value of the function, as you know, we have to use if you use the original function, then that would be easier for you to solve this equation. So as you can see here, there are two factors we can find out from here. 7 times 3 is 21, 7 plus 3 is 10. So these are the two factors, 7 plus 3. So x equal negative 7 and x equal to negative 3. These are the 2 points for which the y value is 0. So use the order pair button to enter your answer. So we have to put negative 7 comma 0. That's for the first x-intercept. And then negative 3 comma 0. Remember, the x-intercept means the y coordinate would be 0. So now the y-intercept means what happens if I put x equal to 0 in this function. That's the y-intercept, x equal to 0 in this function. So that means this x term, it would be 0, then remainder would be 21. So in order pair, the y-intercept would be 0, 21. So here they are asking us to use the order pair, so 0, 21. That's the y-intercept. And now the graph, as you have, as you can see, you have all the information, -5, -4. So -5, -4. That's our vertex. We can use x-intercept and y-intercept. X-intercept is -7, 0. If that point is available and plottable, -3, 0, and then 0, 21. These are enough points, we can use to plot the graph. Oh yeah, 21 is not plottable because if you look at the frame here, this y value goes up to 20, so I cannot plot this 21, so just forget about this. Now I can just use the vertex here and these points here. Yes, you just have to click one of the points, okay, after clicking the vertex. Axis of symmetry, it's x equal, the x coordinate of the vertex is your axis of symmetry. So x equal, what is the x coordinate of the vertex? It's the vertex is -5, so x equal -5 is our axis of symmetry. So determine the minimum or maximum value for this graph. As you can see here, the minimum value is this one, which is at -5. The value itself is -4. There is no maximum value. The function has minimum value because a is greater than 0, and then minimum value of f is -4. Remember, the value of the function is the y coordinate of the vertex. That gives you minimum value. So in interval notation, the domain is as usual, it's all real number here. There is no restriction, and the range comes from the vertex starting from -4. The y value goes up to infinity. If you look at the graph, it's starting from -4, it goes up, so that is the y value. That's the range. Let's go to next problem. Graph the parabola. I'm going to skip it. Do exactly like number 2. Yes, this is also about the parabola, so I'm going to skip it. Find the domain and range. I already discussed about those questions. Number 5, very similar question, so I'm not going to do that. Answer the question. This is our parabola. As you can see here, does the function have a minimum or maximum value? That depends on the coefficient of x square. If the coefficient of x square is negative, you will have maximum value. If the coefficient of x square is positive, you will have the minimum value. So in this case, because x square has coefficient -2, that's why it will have maximum value. What is the function's minimum or maximum value? Because this is the parabola, and as you can see here, the graph, when a is negative, the graph of this function would look like this, and that vertex h comma k gives you the maximum or minimum value. In this case, it's a maximum value, and for finding the value itself, you need to find the k. Here h can be found by using this formula (b/2a). If your function has given like in this form, ax squared plus bx plus c form, okay, so you need to compare this one with the given function here. In the problem, g of x is -2x squared plus 4x. So the meaning a is this number -2, and b is this number +4, and c is 0. So if you put this value of b, which is +4, 2 times a is -2. So we are dividing -4 by -4. That gives us 1 for h. And the value of k can be found by using this h in the given function. So you need to find the value of function g at h, which is 1. So put x equal to 1 here. That will give you -2 times 1 plus 4 times 1, which is eventually +2. So this one This one is 1 comma positive 2. So what is the maximum value? 2 is the maximum value. So 2 is the maximum value. Where does the minimum or maximum value occurs? As you can see here, the x coordinate is, you can answer that question by looking at this x coordinate, which is 1. So that is, check your answer here. So that's the answer. Let's go to next problem. A ball is thrown vertically upward. After t seconds, its height is given by this function. Remember, this function is quadratic function. So to answer this question again, what is the maximum height? The maximum height can be found at vertex. So you need to find the vertex of this quadratic function. Okay? And by doing the same thing, we did here, like here. How did we find the vertex? By using this formula, do exactly the same thing for this function. This time the function is h of t equal 52t minus 16t square. So find the vertex, and that will give you the maximum height at the vertex, and then you can find that height. I'm going to skip it. To solve this quadratic this inequality, first of all, whenever you have inequality, first of all you have to find the zeros. Okay, so this is problem 8. So x plus 1, x plus 6 is greater or equal to 0. So you want to find out where this product gives you positive or 0. So the way we supposed to do is, first of all, find where these factors they give you 0. So solve this one. So x equal to -1 and x equal to -6. These are the 2 points where this product would be 0. So just plot these 2 points, -1 and then -6 is here, -1 is here. So at these 2 points, this product would be 0. So now using these 2 points, now divide this real number line into different intervals. So -infinity up to -6, -6 up to -1, -1 up to positive infinity. So from each of these interval, take some testing point. Testing point means from here, pick something. Let's say I'm going to pick x equal -7. From here I'm going to pick x equal -5. From here I'm going to pick x equal to 0. You can pick anything from this interval. Okay, and now find out the value of this product. What happens to this product at x equal to -7? So if I put x equal to -7 here, the first product would be negative, second product would be negative. So you see, I'm trying to find out this product at -7, and if I do that here, the first number is -6, the second number is -1. Negative times negative is positive. So that means this product would be positive here, positive on this interval. By doing the same thing, I'm going to calculate x plus 1 plus x plus 6 at next testing point, which is -5. That gives me -5 plus 1, -5 plus 6. So which is -4 times +1, which is -4. So here, the product will be negative. If I put x equal to 0, that gives me the product positive. So I'm interested to find where this product would be positive. So the product would be positive here and here, and where it's 0 as well. So this equality sign means I also have to include this -6 and -1. So my answer would be from -infinity to -6 including that, and from -1 to positive infinity including that. So these are the interval where the function would be either positive or 0. So we have to plot that thing at -1, at -6, and then from -6 to this side, and from -1 to this side. So that's my answer. You see? Okay. Very similar idea, so I'm going to skip this this problem. Just do exactly the same thing I did. find out where these products are 0, find the testing point, divide your real number into different intervals based on how many zeros you are going to get, and from each of these interval you find the testing point and check where this product of the factors would be negative or 0. Okay, so very similar question. For each function graph below, state whether it is 1-to-1. So it's very easy if you use the horizontal line test. This is not 1-to-1 because a horizontal line will intersect at more than 1. This is 1-to-1 because no horizontal line can intersect this line more than once. Here this is no. The same idea, use the horizontal line test and you can find out this information. Okay, the two functions are inverse. For finding either two functions are inverse or not, you have to find out the composition of these two functions, meaning find out h composite k and it gives you x, and if k composite of h again it gives you x, then that means they are inverse of each other. So in this problem, if I try to find out h composite k of x, which is actually the value of h at k of x, meaning I'm going to look at here h, and wherever I see x I'm going to replace that x by k. So my composition would be 2 times h minus 5, but eventually I need to put the value of 2 times k, because I need to replace this x by k, and I need to finally replace this k by x plus 5 over 2. So if I do the simplification, x plus 5 minus 5, that is x. So this one is true. Okay, we have to do the same thing for the second part, which is k composite hx, which is finding the value of k at h. So go back to the function k, and wherever you see x in that function, replace that by h, and eventually plug the value of h here, which is 2x minus 5 plus 5. This 5 and 5 cancel out, this 2 and 2 cancel out. So from both directions they are giving you x, so that's why these two functions are inverse of each other. Find the inverse. For finding the inverse, there are steps you need to follow. The first step is first of all, this is number 13. First of all, write down your function as in term of y, 4 minus x over 8. And then second step is, that's your first step. Second step is exchange x and y. X equal 4 minus y over 8. So that means exchange x and y notation. Eventually solve for y. For solving for y, just multiply both sides by 8, and then eventually y is equal to, if I bring y in this side and 8x to that side, it will be negative 8x plus 4. So this y is our inverse of original function. So negative 8x plus 4. So that is our inverse function, negative 8x plus 4. That's our inverse function. Find the inverse. I'm not going to repeat the very similar type of problem, so let's go to the next problem. Find the inverse again. Do exactly the same thing I did. Given the domain of 1-to-1 function, f is this and the range of this, state the domain and range of the inverse function. So remember one thing, the inverse function, they have opposite domain and range, so it's a reverse process. Okay, so I'm going to so let's say you have a function here, f of x, and the domain of this function is D and then R is the range. Then when you find the inverse of this function, the domain of this function would be R and then range would be D. So it's just a switch, it's just reverse. So the domain of f inverse is actually the range of the function. So this is your domain for the inverse function, so which is -1 to +infinity. And then range is the range of inverse function is the domain of original function, so which is negative it's not negative infinity up to negative 5. So it's just the reverse. Okay, what did I do wrong? Oh, I have to put the parentheses. I use the bracket, so it's supposed to be negative infinity up to negative 5, which is supposed to be parentheses. To plot the graph of inverse function by using the function itself, just switch x and y coordinate. For example, here, and for this is just three different straight line, right? So the line joining these 2 points, line joining these 2 points, and line joining these 2 points. So 1 2 3 4 different points are very crucial here. So the first point is 5, 6. So instead of 5, 6, because you are looking for the inverse, just switch that coordinate. 5, 6 becomes 6, 5. So I'm going to plot 6, 5. So that's the inverse of this function. So inverse of this 4, 0 is 0, 4. Just switch x and y coordinate. Inverse of this 0, negative 5 is negative 5, 0. I'm just switching x and y coordinate of these 4 crucial points. Inverse of this point, which is negative 7 and negative 6, inverse is negative 6 and negative 7, meaning I'm just switching x and y coordinate for each of these points. Now we just have to join these points, like from here to here, from here to here, and from here to here. Remember, the inverse function should have the mirror image. If you place a line through the this origin, y equal x line. So this is our inverse graph. Graph the exponential function. So as you can see here, this negative exponent and this 5/4 is greater than 1. So the answer would be, you can find some points. For example, if you put x equal 0, then the value of exponential function is 1 always. So that's the first point I would start with. If x is, let's say, negative 1, the y value, if x is negative 1, the y value would be 5/4 to the power negative times negative would be positive. So it will give me 5/4. Okay. If x is, let's say, positive 1, then y would be 5/4 to the power negative 1, which is eventually 4/5. 4/5. You see that? What did I do? I just did, if I try to find out the value of the function at 1, it would be negative 1, which is actually 1/5/4. If you reverse this, you have to, that's how we simplify the terms. It gives you 4/5. Okay, how many points do you need? 5 points. So 3 points, and then you can also choose, let's say, at negative 2. Negative 2, if you put negative 2, that will give you 5/4 square, which is 25 over 16, because 5 square is 25 and 4 square is 16. And if I put negative 2, that will be opposite, that's a 16 over 25. 16 over 25. The way we did it here, positive 2 would be 5/4 to the power negative 2, which is 1/5 square over 4 square, which is eventually, you see, it's 1/25 over 16, but the denominator, you have to just flip it. That's the rule of the denominator. Whenever you are dividing by some fraction, you have to flip it. 16 over 25. What did I do wrong? At negative 2, 16 over 25. At positive 2, no, it's not negative 2, it should be positive 2. Okay, yes, so these are the 5 points. We can use this one. Okay, 1 2 3 4 5, yeah. Okay, asymptotes would be for this one, it's always y equals 0. That's asymptotes, we did that. Now this is the graph. Remember, you also have to put the asymptotes, that's what they are saying here. Very similar idea, but this time it's a translation. You also have to use the translation. This is the graph of 4 to the power x. 4 to the power x minus 1 means it's a horizontal shift to the right 1 unit, so that's 1 unit to the right. Okay, and then plus 2 means 2 unit up, 1 2. So this graph comes from the very same graph, but horizontal translation to the right because you are subtracting 1 from the x coordinate. So it's a horizontal translation to the right 1 unit, and then plus 2 means vertical translation up 2 units. So from here 1 unit to the right, 2 unit up. Okay, so this is the graph we have given. We need to answer this question: what is the range? Range is, this is the maximum value, which is -2. So that means write your answer as inequality. So range is y is less than or equal, not equal, sorry, it's a less than. So what is the value? -2. It never touches this -2. That's why we have this dashes line. That's the asymptotes. And domain is all real numbers. So how do you write it? All reals. Yeah, we have that option. Very similar idea like we did in problem 19. So I'm going to skip that. Yes, this is also very same idea. Use the translation. +1 means left shift 1 unit. -6 means vertical shift down 6 unit. Okay, and find the domain and range. After finding all this thing, finding the domain and range is very easy. Okay, what is e to the power -0.25? Just use the calculator given here. Just use e. What is e? E to the power negative 0.25. That's 0.77. Do not round any intermediate step. Round your answer to the nearest thousand, means after decimal use 3 decimal place 0.778. But when you try to round it to the third decimal, you also have to look at the fourth one. If it's more than 4, then you have to round it to the nearest, this 8 becomes 9, so the answer is 0.779. By doing the same thing, just find out this: 225 times e to the power 0.2 times 274.816. 274.816 if you round it to the nearest thousand. Solve, make the same base both side if it's possible. So that means there is a 2 to the power -6x. So can you write down this 64 as a 2 to the power some number? If you, then that would be easy problem for you. So 64 can be written as 2 to the power let's say 2 3 4 5 6. 2 to the power 6 is your 64. And then there is another power, which is 3 minus 2x. So 2 to the power -6x. Remember, power to the power is multiplication. So you have to multiply 6 times 3 is 18. 6 times 2 is 12x. So if you have the same base, their exponents should be equal. So that is the one good thing we can use about the exponential with the same base. A to the power x, a to the power y. That means x and y has to be equal. So now solve for x. There is a -6x, so I'm going to add 2x. So that gives me -4x equal 18. Just divide both sides by -4. That gives me -9/2 for the x. So x is -9/2. negative 9 over 2. That's the x value. What did I do wrong here? So let me double check my work. 2 to the power negative 6x, 2 to the power 6. So is 2 to the power 6 is, okay, let's go back here and then use the calculator. Where was the calculator here? No, number 23. Okay, here is the calculator. 2 to the power 6, 2 to the power 6, is this 64? Yeah, that's 64, that's right. So 2 to the power 6, 6 times 3 is 18, 6 times 2 is 12. Oh, look at here, it's supposed to be negative 12 and I have 2. It's not 2, it's 12, so I have to add 12. If I do that, 12 minus 6 would be, okay, you see, I have to redo this thing here. Instead of positive, there is a negative 12, so I have to add 12x. So that's the reason my answer was wrong. So it is 6x equal 18, and if I divide both sides by 6, x equal 3. So that's supposed to be the answer. So I was wrong there, so just replace this by 3. Great. Yeah, sometimes mistakes happen, so make sure that you double check your work. So this is same idea, just replace on the left side, this is 2 to the power 2c plus 8. Can you write down 1 over 2 as a 2 to the power something? Can you? The answer is yes. 1 over 2 can be written as 2 to the power negative 1. 1 over 2 and 2 to the power negative 1, that's the same thing. So replace this half by 2 to the power negative 1 and multiply this negative and c plus 1 and solve the way we solved the previous problem. Okay, very same idea. E to the power 2x plus 2, if you bring this e4 to on the exponent, the top position, this is what you are going to get. Look at here. So e to the power 2x plus 2, and on the right side you can write down e to the power negative 4. So just equate this one and solve for x. Okay, this is a interest problem. This is compounded monthly, so you need to use a formula for this. Okay, so for this particular problem you have to use formula. This is the compound n times a year formula. So what is the problem? Brian deposit 4,000, so this 4,000 is the principal, and in an account with the 3.6% interest rate, so R is 0.036. Whenever you see the percentage, just divide that number by 100, that will give you the value of R. Compounded monthly means n equal 12. If it's compounded monthly, then you have to count how many months are there in a year. So there are 12 months, so that's the reason n is 12. Assuming that no withdrawal are made, how much will he have in the account after 10 years? So t is 10. So just use this information here. So the A stands for amount after 10 years, so it's a 4,000 1 plus 0.036 over 12. N times t means 12 times 10 is 120. Just use the calculator, like here it's as you can see here, 1 plus 4,000 times parenthesis 1 plus 0.036 divide by 12, and then go to parenthesis close, power 120. That's what we have here. Just hit enter. That gives you the answer. Do not round any intermediate computation and round your answer to the nearest cents. It's a 5,730.23 cents. Okay, 5,730. What is that? I supposed to write here 5,730.23 cents. Good job. An initial amount of 1500 is invested in an account at an interest rate of 9.5% per year, compounded continuously. Assuming that no withdrawal are made, find the amount of account in after 4 years. So this is compound continuously. This is not the same formula. You have to use different one here. A equal P times e to the power R times T. This is the compound continuous formula. In this problem, principal is given 1500, rate is given 0.095, and time is given 4 years. So you just have to use this thing here, and your answer would be 1500 times e to the power 0.095 times 4. So that gives me 2193.43 cents. 2193.43 cents. That's the answer for compound continuous. Let's go to the last problem here. Mr. and Mrs. Ross hope to send their daughter to college in 14 years. How much monthly should they invest now? At an interest rate of 8.5% per year, compounded continuously, in order to be able to contribute 9,000 to her education. Remember, this is the formula for compound continuously. They would like to contribute 9,000. So the value of A is 9,000. So this is the compound continuous formula, and they want to have 9,000 after how many years? So how much money should they invest now? So remember, they want to find out the principal. What's supposed to be the principal invested now, so that they would have $9,000 after 14 years. So you are looking for P, e to the power, rate is 0.085, time is 14. So just find out the P. For finding the P, just do this calculation and divide this 9,000 by this number, which is e to the power 0.085 times 14. Use the very same calculator. This time you have to divide 9,000 by e to the power 0.085, what is that, times 14, and that will give you the amount of money. This should invest 2,737. If you round it to the nearest cents, it's supposed to be 0.99 cents. Yeah, this would invest this much amount of money to have 9,000 after 14 years. Okay, so that is practice test for test 4.